Hi guys, I'm G. Kanika Devi. In this video, I'm going to talk about compression techniques. Compression. First of all, what is compression? Modern computers can store increasingly large number of files, but file size still matters. The smaller our file size are, the more files we can store. We use compression algorithms to reduce the amount of space needed to represent a file. In this image, you can see 50 KB of file can be stored into 20 KB by using compression algorithms, thus by saving large number of storage. Types of compression. There are two kinds of compression, lossless and lossy. Lossy compression loses data, while lossless compression keeps all the data. Lossless compression allows the potential for a file to return to its original size without the loss of single byte of data when the file is uncompressed. What are the different image compression standards? Compression is of two types, of course, lossy and lossless. In lossy compression, the reconstructed image contains degradation. With this, perfect reconstruction of the image is sacrificed with respect to the original image, but higher compression ratio is achieved. This is used commonly in multimedia applications. What is compression ratio? The lower the compression ratio, the better the quality and the larger the file size. The higher the ratio, the smaller the file size, but the greater the loss of information. Compression techniques: image compression, data compression, vector quantization, compression algorithm, compression ratio, lossless compression, lossy compression. Compression techniques: image compression. In the field of image processing, the compression of image is an important step. Before we start the processing of larger images or video, the compression of image is carried out by an encoder and output a compressed form of an image. In the process of compression, the mathematical transform plays a vital role. A flowchart of the process of the compression of the image can be represented as an image goes through multiple transformation to form a compressed image. Data compression. In information theory, data compression, source coding, or bitrate reduction is the process of encoding information using fewer bits than the original representation. Any particular compression is either lossy or lossless. Lossless compression reduces bit by identifying and eliminating statistical redundancy. No information is lost in lossless compression. Lossy compression reduces bit by removing unnecessary or less important information. Typically, a device that performs data compression is referred to as an encoder, and that one, the reversal of the process, is a decoder. Vector quantization. Vector quantization is a technique used in data compression, signal processing, and pattern recognition. The process involves partitioning a set of data into clusters, assigning each data point to the nearest cluster based on distance or similarity, and constructing a compact representation of the data by using the cluster center. In simple terms, vector quantization is a method of reducing the amount of data needed to represent an image or signal while maintaining its quality. Lossy compression. Lossy compression is a method of data compression in which the size of the file is reduced by eliminating data in the file. In doing so, the image quality is sacrificed to decrease file size. Any data that the compression algorithm deems expendable is removed from the image, thereby reducing its size. Lossless compression. Compression can be lossy or lossless. Lossless compression means that as the file size is compressed, the picture quality remains the same. It does not get worse. Also, the file can be decompressed to its original quality. Lossy compression permanently removes an overview of which file types work best for each type of image. GIF. If animation is required, line drawings and simple graphics. JPEG. Photos, especially without high contrast. Screenshots, especially of movies, games, or similar content. PNG. Line art, illustrations, photos with high contrast, transparency, especially alpha channel transparency. Application screenshots or other detailed diagrams. Video compression. Video compression is the process of reducing the size of digital video files while maintaining an acceptable level of visualization and audio quality. This is crucial for efficient storage, streaming, and transmission of video content. Video compression techniques are used extensively in various applications, including video streaming, video conferencing, video storage, and digital television. Here's a detailed overview of how video compression is applied. Video acquisition. The video compression process starts with the capturing or creating video content using cameras, cam recorders, or other video recorded devices. This video is typically represented as a sequence of images captured over time. Frame rate adjustment. In some cases, the frame rate of the video may be adjusted to reduce the amount of data to be compressed. For example, converting a 60 fps video to 30 fps reduces the number of frames per second. Color space conversion. The video may be converted from the RGB color space to another color space such as ICBCR. This separation of luminance and chrominance can improve compression efficiency. Intra-frame compression. Each frame of the video is compressed individually. Spatial conversion techniques are applied within each frame to reduce redundancy. Key techniques used for intra-frame compression includes transform coding, applying mathematical transforms to represent the image in a more compact form, quantization, reducing the precision of transferred coefficient with more quantization applied to high frequency components, entropy coding, entropy quantized coefficient using techniques like Huffman coding or arithmetic coding, intra-frame prediction, predicting pixel values of based on neighboring pixels and encoding the prediction error, inter-frame compression. To further reduce redundancy, inter-frame compression techniques are applied between frames instead of encoding every frame independently. Inter-frame compression identifies and encodes the difference between key frames. Key techniques used for inter-frame compression includes motion estimation, determining how objects move between frames and generating motion vectors. Motion compensation, using motion vectors to predict the content of a frame based on the previous frame. Inter-frame prediction, encoding only the difference between the predicted frame and the actual frame. Group of pictures, dividing the video into GOPs where some frames are fully encoded while others are uses interframe compression. Audio compression. If the video includes audio compression techniques are applied to reduce the audio data size while maintaining audio quality. Compression and container format. The compressed video and audio data are combined and stored in a specific container format such as MP4, AVI, or MKV. The container format includes header, metadata, and synchronization information. Storage or transformation. Storage or transmission. The composed video file can be stored on storage devices or transmitted over networks. Example for streaming, broadcasting. Decoding. To view decoding. To view or edit the video, the compressed data is decoded by reversing the compression steps. This involves decoding the video frames and audio data, reconstructing frames using intra-frame and inter-frame decoding, comparing audio and video stream, optionally applying color space conversion and frame rate adjustment. Hereby I have explained the various techniques of compression. I hope you understood that. Thank you.